Alrighty, so yesterday we did example 2. We came up with quadratic for that. We read example 3 and we labeled that this would be in months and this would be in kilograms, right? And then that's as far as we got because we just stopped there. So let's just reread this. The weight of newborn babies can be modeled by a linear function. And again, it tells me that right there. On that test that I just graded of y'all's, there was a question that's literally, it told you, use a linear function. And I had multiple people give me a quadratic. I don't know. So like I don't even have to make a decision here. For the 4 months after birth, selected values of the weight, W of T, in kilograms of a particular newborn baby are given in the table above, where the T represents the number of months. Okay, so we got the weight in kilograms, T is the number of months. Use the regression capabilities on your calculator to find a linear model in this form right here for the weight of the particular baby X months after birth. So go ahead and go into Desmos, and this was, is that the right? We're on example 3. Okay, let me get the, go ahead and find your regression. I got my stuff typed in, so I don't have to stand up here like a moron to try to type it in. Get your linear regression there. And I think that a linear, I mean, that looks pretty decent to be linear, right? So then we go over here and we're going to write this down. Now, it did literally tell us to use X, and we have this stuff right here, so we can use it in terms of X and Y. So go ahead and write your regression down that you got. Oops, that should be X. Okay. Now, can we copy it down exactly like it looks in Desmos? The answer is no, because Desmos gives you y equals mx plus b, and this says y equals a plus bx. It's still a line. It's just putting it in a different order, because for some reason in statistics, that's how lines are usually written. For what purpose, I don't know. I'm sure there's a good reason. I just don't know what it is. All right, so, and this is, again, technically y hat. If you don't put the little hat on it, it's not the end of the world, but I'm going to continue to do that because I just think it makes things make more sense in the long run. Everybody good on that? Easy enough? Yes? Okay, so then it says to use the model found in part A to predict the weight of this baby 2.5 months after birth. Okay, so here's what we don't do. We do not substitute it in by hand and type a bunch of numbers back in. Okay, we do that if this is a non-calculator and we have to evaluate g of x at 2 or whatever, and then yeah, maybe we have to do some stuff by hand. But we let the calculator do everything when it has given us weird decimals. So is that 2.5 my input or my output? Input. And in Desmos right now, I have everything in terms of x and y. Remember, we could type something in as w of t and use w and t, and that is fine, but that is not what we did. Everything's in terms of x and y. So this is actually the x value. So knowing that, I can come over here and just type in x equals 2.5. And then it gives me a vertical line here. And so when x is 2.5, or when the input is 2.5, my output is 5.34. So that means that basically it was w of 2.5 that it asked me for. That is 5.34 what? Kilograms. And I don't even have to think about it because I already had it labeled. I don't have to go dig through my equation or anything. Okay, we good with that? What questions do you have? Okay, then it says the actual weight of the baby in 2.5 months after birth is 5.5 kilograms. What is the residual for this weight? Okay, so if I'm going to find residual, what order do I subtract in? Actual minus predicted. Very good. Now, they gave me the actual. So my residual equals the actual, which is 5.5, minus the predicted, which we just found, which is 5.34, and that gives us 0.16. Okay. Then it says, did the model underestimate or overestimate the weight of this baby? Well, we got two ways to look at this. We know what the residual is, so we could reason through it that way, or we know exactly what the predicted and exactly what the actual was. Here's my predicted. Was this an overestimate or an underestimate for this? Underestimate. Very good. Okay. Any questions at all? All right. So then it said, would a quadratic regression be a better model? Explain. Okay. So here's my linear. And I can turn that guy off just so he's not there. If I did, and it doesn't look so bad, quadratic kind of looks better, but I can't say quadratic looks better because it goes through the points better. Like, that's not what we're talking about here. We want to, so if I go back to my linear, we want to look at the residual plot. So I'm going to plot my residuals. So you hit plot, but then make sure that when you hit plot, you are changing, like you hit the magnifying glass so that you can see it better. And I don't really like that those are a little harder to see because they just happen to be, oh. Yep, so I gotta do it this way. I'll make them red, makes them a little easier to see. Turn back on, I didn't mean to turn off. Oh my gosh, done. Jesus. All right, so do you see a pattern? Yes, I think we have a very clear pattern, right? It looks quadratic, which does not mean that quadratic is the way we should go or anything. It's not how that works. It's just a coincidence. So then when I look at the quadratic one, when I do that, okay, don't forget to hit your little magnifying glass again so you can see it better. So now when you look at that, that looks like a pentagon. But that doesn't mean anything. That's not the, what's that about? Okay. It looks like a pentagon, but that's not the kind of pattern we're looking for. As far as just where the points land, that's definitely more random than this one is, right? And when I go back to linear, I can't see anything, so I click that, okay? So if I had to choose between the two, I think the quadratic definitely looks better there. So we can say that, would quadratic be a better model? Yes. Residual plot for linear shows a clear pattern quadratic does not. Okay. All right, so you're not going to have to explain these on the AP exam. They will be multiple choice questions, but we're going to do it on the notes. You may have to do it on a quiz or a test for me, just so that I know that you understand it and you're not just randomly picking answers in multiple choice. But you don't have to be as fancy or as specific with your words. Does that make sense? I mean, most anything you put can be in your own words, but there are the things that we have to explain on the exam where it's probably better if we just follow the formula so that we make sure that we say the exact right things. You don't have to be as worried about that on this, okay? Any questions? All right. So then this says an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. Which of the following is the best conclusion about the appropriateness of the exponential regression model based on the corresponding residual plot? So always make sure you know what you're looking at. We are looking at a residual plot. Okay, we're not looking at like a graph of the data itself. And so when I skim the answer choices, never skim the question. You can, at first glance, skim the answers before you really read them. And notice that they all start kind of the same way. The exponential model is, and then either appropriate or not appropriate. From that residual plot, would you say appropriate or not appropriate? Appropriate, right? So I can mark those out. And then it's appropriate because the residuals show no pattern, right? That's kind of random, so that is my answer. Okay. What questions you got? We good? All right, great. So grab that sheet of paper you picked up on the way in. It's going on page 59 as well. Okay, so when you look at the residual plots, if this does not show a pattern, then it's a good, appropriate model. If it shows a pattern, like if the dots went like this, then that would show some sort of pattern, then that is not appropriate. Does that make sense? Good. Thank you for asking. Anything else? Okay, good. All right. So while driving down a dirt road, you punctured the tire of your truck. The table below shows the pressure Y measured in pounds per square inch. If air in the tire at any given time X measured in seconds after the tire was punctured. So here's my data, and then it says find an exponential function in this form that best fits the data. So go ahead and go into Desmos and type your stuff in and get your exponential model. That is that one, right? And once I have it typed in, and we choose exponential because that's what they tell us to do, what else do I need to do? Log mode. Now, one thing when we write these down, I've said it a few times that what you see right here, if you do not see at least three decimal places, then we need to hit these little three dots here, and then export as a custom regression, and it exports it like you've seen before. But what I've noticed over the past few days is that what they're showing us actually is more decimal places than we had. And so on that test that I had gotten in the grade book yesterday, one of the issues with some of you was that what it gave you up here, like whenever it did the regression, it didn't have three decimal places, and you didn't do that, and then you got it wrong. Another student, and then I did it as well, put in the data, the same data, and now we see more decimal places. So when they're updating the stuff, they're not telling us, hey, we updated this, hey, we updated that. We just kind of figure it out along the way. So I think maybe you might be okay now just looking at this, but just on the safe side, double check. And if you don't see at least three, then export it. But if it is something you had to click log mode on, when you export it, you have to click log mode again. Okay, so anytime you see that, just make sure that it's checked. So I wouldn't necessarily need to do this here. I just wanted to remind you that that could possibly be a thing. And so we're going to write down, let's see, I still think we need to write down 4 decimal places here. So y equals, really y hat equals, I have 33.8795, and then I'm going to put the b part in parentheses. Do you have to? No, but you don't want your multiplication sign to look like a decimal, and you don't want it to look like it's just all crammed together either, okay? So it's really, that's kind of best practice, even though it's not written right there like that. Okay, everybody good so far? Okay, so then it says, using the model, what was the pressure of the tire before it was punctured? All right, so tell me, in this situation here, when was the tire punctured? At what? At 0, right? At 0 seconds, it says X measured in seconds after the tire was punctured. So the tire was punctured at time t equals 0. But this doesn't say when it was punctured. It said it was before it was punctured. So I, like a lot of you, overthink everything. And this was a part of the question that got changed this year. And I was like, well, before it gets punctured, is there somebody knocking? You got to knock louder, dude. I can't tell when I can't hear. All right, so if this is when it got punctured, before it got punctured, does the graph really make any sense in this problem situation? It doesn't, because your tire would have long since exploded. Plus, we don't technically have negative time, but that is the time before it got punctured. And so somebody earlier today said, well, before it got punctured, from here, shouldn't we just have like a horizontal line? And said yes, because in math, a lot of times we just ignore physics, right? We ignore the wind, and we ignore all the other factors of things, and we just do what would happen like in a perfect world or in a vacuum or something. But even if my tire's not punctured, the tire pressure is going to fluctuate at least a little bit. And I know a lot of you drive, but if you do, you haven't been driving for years and years or anything. When it gets really cold, you'll see a line outside a discount tire because everybody's there to get their tires inflated because they think they're all low on air. But when it's cold, your tire pressure drops. So when you drive and your tires warm up, even if it's not cold outside, the tire pressure is increasing. So before this, it's not, in theory, it's a straight line because your tire pressure is what it is, but it does fluctuate some. So I just think that this probably needs to be reworded a little bit. I think it's using the model, what was the pressure of the tire? Let's just say when it was punctured, and then I don't have to overthink it, and neither do you. Because that's really what it's asking. So then we have to know when it was punctured, and it is at time equals 0 because of what it says. Do I even need to go back and look at the graph for that? And the answer is no, because isn't A your initial amount? Because if time is 0, that makes the b to the 0 power, that makes that 1 times A. This is your initial amount. But if we look at the graph and we click on that, that's the same number, right? And so that is the tire pressure. So Y equals 33.8795. And what are the units? PSI. Do you have to understand what that means? No, you do not. You just use what's there, okay? Everybody good with that? Yes, sir. Because it's an approximation. All right, and then it says to plot the residuals, explain what you see in the plot. What does it tell you about the validity of your regression? So we'll go over here. Let's plot our residuals. So we just click plot, and you don't necessarily have to turn everything else off. When I zoom in, I can't even see the other stuff, so I don't necessarily need to turn it off. If the graph for some reason went through those, I'd probably want to turn it off so I'm not confused. Or if the points all happen to be the same color or something. So this is your residual plot. Do you see a clear pattern? No, and it's not an ink blot test. Nobody's like, do you see the bird there? He's facing left. Like nothing like that, okay? It's like, do you see, does it look like a quadratic? Does it look like, and it doesn't have to be specifically a graph either. So yeah, I'd go with no. Maybe, if it was a constellation or something, we could figure something out. But that's not what we're trying to do. I do think if we did another one, like even quadratic looks pretty good, right? But it's all a matter of, it just asks you, so we're not saying that this is the absolute best, but does it seem like it's valid? Yes, it seems like it's valid, right? So we can say then, explain what we see. So we can say something like the residual plot does not show a clear pattern and then we can use the little 3 dots. Do you remember what the 3? Oh, that's 4. What does it mean? Therefore, yes. So 3 dots, little 3 dots for a big word. Therefore, the model is valid. I guess that's a good way to say it. It's the way it's worded, or, you know. Or the regression model is good for the data. Like, we don't have to be fancy or anything, but. Any questions about that? That makes sense? It's all about, do you see a pattern or do you not see a pattern? That kind of thing. All right. So then, example 6. A set of data has an upward trend shown in the plot below. It is not clear whether the best fitting function is linear or exponential. Use the residual plots to determine the regression function would best model the data set and explain why. Okay, so it's also important with these graphs that you pay attention and you understand what you are looking at. This is the data plot. This is actually the old school X and Y that we're so used to, right? That's just plotting the data points. And as you can see, like, I think maybe we could make that a linear, or maybe we could make it exponential. Maybe we could even say it could be quadratic. Like, that's not one of our choices here, but that's another valid way to do things. And then these two are the residual plots. Okay, so that's when this is your y hat, right? The first one and the last two, completely different things from each other, all right? So just make sure you know what you're looking at. Do you see a clear pattern in either one of them? Yeah, I would say in the first one, I mean, this, you can kind of see something quadratic-y in there, at least more so than the second one, right? And so I would say that, yeah, that this one is probably not good. We see a pattern. So, no, and then we can say this has no clear pattern. And that's why we like this one. Okay. Any questions about that? And I think that some of the ones that we've done on Desmos, like maybe it's a little questionable about whether there's a pattern or not. I really believe in my heart of hearts that when you're asked these questions on the real test, or even a real test that I give you, it's going to be pretty obvious. You're not going to have to overthink it. Don't worry about that. All right. So then example 7. A group of AP pre-calculus students used a set of data to create linear, quadratic, and exponential regression models. After creating the 3 models, the students created residual plot for each model type. So the residual plot for each model type, and that says see above. So yes, they created the other regressions. We don't see those, okay? They did label them, but we don't see what they are. So based on the three residual plots above, plus they're actually labeled. So there's no question about what you are looking at, okay? This is your y hat. This is your y hat. This is your y hat. Remember, we just laid it down. Okay? Which model is most appropriate for the data? Give a reason for your answer based on the residual plots above. Okay, so for this first one, do you see a clear pattern? Yes, I think it's a very clear pattern, right? Like, you can pretty much connect the dots, so we don't like that one. In the second one, we do see a clear pattern. Now, we had a pattern that was kind of similar to that on another one we looked at yesterday, but we thought it was okay. If I had to choose between these two to say which one's better, I would definitely say that the quadratic is better. Would you agree with that? Because this is kind of a pattern of a trig function, which I know you don't even know what that is yet, but between the two, that one's better. But then when I add this one into it, overall, the least patterny one, I would say, is this one, right? Would you agree with that? And so we can say, how do we give it, based on the residual, which models? Okay, so we can say exponential, so the exponential model is most appropriate. And notice we are not saying that like it is the best one and this is absolutely 100% the exponential model. Maybe there's something else out there that's better, but between these three, this is the most appropriate. Most appropriate because the residual plot, I cannot say it because that would make absolutely no sense. The residual plot shows no clear pattern. What questions do you have? We good? All right. I'll flip it over. Mr. Passwater hopes to make it into the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles in various sizes, where each circle is painted a different color. He wants to create a model to determine how much paint is needed in quarts for a circle of radius r in feet. Yes. I can't kick you out? Okay. All right. You're good. You too? Okay. Bad children. And I think we determined it's because like we're doing this. Did you do that? I'm just curious. I'm not. Okay. You tapped it and it didn't like that either? Okay, yeah. But if you go back to Canvas, you should be able to get back in. Just go back to your portal. You should be able to get everything. So it doesn't like if you tap or if you swipe. So I don't know how you're supposed to wake up your computer, but whatever. All right, so it says, should Mr. Passwater use linear, quadratic, or exponential model in this situation, and explain your reasoning? So remember, we have to choose an appropriate model. We might have data and we get to graph everything. We might have a residual plot and we choose from that. Maybe we just have a problem situation and then we need to choose from that. So given what's happening here, what do you think would be the best? What is he trying to do? Or what? He's going to paint circles, right? So if I have a circle and I'm going to paint it, what do I need to know about that circle to figure this out? Area. And so if I'm going to use area, which one am I picking? Quadratic, exactly. Because remember, that was one of the ways to choose quadratic. There's other ways if we have data, but if it's anything involving area, and y'all been doing questions like this forever. I mean, in junior high, how many times were you asked, you're going to paint the wall. What do you need to know to determine how much paint you need? You need the area of the wall, so you can figure out your paint. It's the same type of thing. So we can say quadratic. And then we can just say he needs to know the area, or he needs to use the area of the circles. That works. All right, so then after creating the model, Mr. Passwater uses it to purchase different special paint colors to use on his mural. In this situation, do you think it is more appropriate for the model to underestimate or overestimate the actual amount of paint, and why? What do we think? Under? Over. Okay. So my under people, why under? Any idea? Okay. Overestimate people, you want to give me an idea? Exactly. If I underestimate, I probably can't fill in all the circles, right? And I heard you over there like way overthinking it, because I'm with you, I overthink everything. And say what you were saying, because, yeah, because. Okay, well, that's not what I thought I heard you say. I thought you said you need to account for like the thickness of the circle or something. But yeah, but if it's special paint colors, you don't want to have to go back. You want to have enough, right? I was like, well, you just buy more. Maybe you can, but maybe you can't. But if like you're covered in paint and you're almost done, do you have to get in the car and go back to the store? Absolutely not. Especially if it was like a special paint color or something. So I think we're going to go with overestimate here. I mean, that's a valid reason. I'm not going to, and it is a matter of opinion, but overestimate, let's see, overestimate. So he has enough paint, something like that. Ugh. He has enough paint to finish. That's fine. It doesn't have to be super formal here. I would think in a lot of things you would want to overestimate. If you're trying to figure out, like, Thanksgiving dinner, how much food do I need for the 8 people that are going to be there? Wouldn't you rather have a little bit too much than not enough or whatever? Yeah, absolutely. The leftovers, too. I'm all about Thanksgiving leftovers, yes. All right. Any questions? We good? Okay. All right. Example 9. Mr. Burst started a new online business selling Bruce merchandise, or Bruce numbers. He made estimates about his revenue and used the exponential regression to help develop a model for his sales over time. The figure above shows the graph of the residuals of the exponential regression. Which of the following statements about the exponential regression are true? So it's asking me about the exponential regression, but it tells me this is the graph of the residuals. And this graph looks more like a normal graph, I think, because most of the residual graphs you've seen have been like in a rectangle with that line in the middle. And that doesn't really have that same look. So make sure you know what you're actually looking at. So would you say this is or is not appropriate? Not. Okay, so we don't like either one of those. And then it's not appropriate, why? There's a clear pattern. Exactly. So we like C. Okay. We good with that? I didn't know residuals are so funny. Okay. All right, then students from an AP pre-calculus class were brought to the gym to shoot free throws. But only the students with little to no basketball experience were allowed to shoot. Each student was given 60 seconds to shoot as many free throws as possible. A regression model was calculated with the student's height in inches as input values and the number of shots made as the output values. The residual plot for the regression model and the data points are shown below. So this is the residuals. It says that. So this is my y hat, right? Then it says the given residual plot has a point labeled P. There's P right here. At the coordinate 62, 4.7. What does point P indicate in the context? Okay, so that point P there, is that a positive or negative residual? Positive, okay, because just like everything else, this is positive, this is negative. Now, I can say that, but that's not what it's asking in the context. So we have to talk about the basketball shots and the kids. It's not just, it's not asking us about anything else. So this coordinate here, this 62, 4.7, what do these two numbers represent? What does this 62 represent in that order pair? His height in inches, right? Okay, so his height in inches. And then is the 4.7, is that the number of shots he made? No. What is it? The given residual plot. So this right here would be 62. This right here is the 4.7. The 4.7 is the residual. So instead of having the input is the height and the output is the number of shots made, which is what the original graph is, the residual plot, it uses the same x values, but the y values change to the residual values. Does that make sense to you? Okay. So that being said, whether we know that's exactly 4.7 or whether we know it is just positive or whatever, does the model overestimate or underestimate? Under, because it's under the point, right? So we can say that the model, or the regression, or whatever you want to say, the model underestimated. What did it underestimate? The number of shots, exactly. It's underestimating the y value of the actual function. So the model underestimated the number of shots made by the 62-inch student, which is a weird way to talk about a student, but I mean, you could say underestimated the number of shots made by the student who was 62 inches tall, but that's a lot of words, and we don't need all that, right? That gets our point across. Do you understand how we determined all the pieces and how they fit together? Yes? Are we good? Okay, so I want you to read B, see if you can write out a sentence for that while I hand out your assignment. Then we'll talk about it. Here, can you tell us? Okay. So I wonder if, did you tap once or did you tap multiple times? Okay. And then the same thing happened? And I'm wondering, yeah, go ahead, go share it. I'm wondering if, like, when you swipe to wake it up, if you don't, like, swipe a bunch back and forth, if maybe that would be, I don't know. I'm gonna have to ask some people what the deal is with that. Okay, so are you able to kind of write the same type of sentence? Yes. You just change a couple things, right? So this time we can say the model did what? Overestimated. Estimated the number of shots made by the 74-inch student. All right, any questions about any of this? All right.